All right, let's just get right into it. Look, you're here because you're good. You find bugs, you get paid, maybe you've got a reputation. That's great. But we're not here to talk about that game. We're here to talk about a whole different league. You see, the difference between a bug hunter and an operator, it's simple. A bug hunter? They're looking for a door somebody left unlocked. An operator? We already own the building. We've got the blueprints, the keycard manifests, we know the janitor's schedule, we know which guard is sleeping with who. That's the chasm we're about to help you cross.
Welcome, everyone. If you came here hoping for a top 10 list of XSS tricks or some fancy new SQL injection payload, you're in the wrong place. There's a million blogs for that. This is a masterclass in mindset. It's about a fundamental shift in how you approach a target. We're going to teach you how to think, plan, and execute like a state-level operator running a full-spectrum campaign. We're going to take you from being a hunter to being an owner. Let's begin.
Okay, here's the mission briefing for this leg of the journey. We call it the operator's journey. First, we're going to rewire your brain with the right mindset. Then, we'll get our hands dirty with foundational OSINT, open source intelligence. That's about building your map of the battlefield. From there, we dive deep into the target's digital brain, their APIs. After that, we hit the modern attack surface, the cloud and the absolute mess that is the software supply chain. And finally, we'll talk about what you actually do with this mountain of intelligence you've gathered. Everything builds on what came before, so pay attention. Let's get into it.
Right. Before you even think about opening a terminal, you have got to reprogram the way you think. Most of us, we're trained to look for that quick win, that dopamine hit of a reflected XSS, or a simple open redirect. And look, those things have their place. But in elite operation, it's all about the prep. We live and die by a simple rule: 90% intelligence, 10% execution. Think about that. For every single hour you spend actually throwing an exploit, you should have already spent 9 hours preparing, planning, and mapping. The keyboard is the last tool you pick up. Your brain is always the primary weapon.
Listen to me. Burn this into your skull. Your goal is not to find a vulnerability. That is a side effect. It's a symptom of the real work you did. Your actual goal is to build a map, a complete, living, breathing asset graph of the target's entire universe. And I mean their entire universe. Every single domain, every IP block they own, every forgotten cloud tenant, every shitty marketing app from 2012, every developer, every sysadmin, every third-party vendor that processes their damn payroll. You're building an intelligence file that would make the CIA blush. Once you understand the system better than the people who built it, the vulnerability just presents itself.
Okay, let's dive into the real meat of it. Foundational OSINT. This is the bedrock of everything we do. This is not about running a few automated tools and calling it a day. This is the phase that cleanly separates the script kiddies from the professionals. If you screw this part up, you're just making noise, you're wasting time, and you're gonna get caught. But if you get this right, well, the path to ownership starts to look real clear.
Look at this slide. This right here, this is the whole game. The hunter approach: they run Subfinder, pipe the results into HTTPX, they get a list of web servers, and they start spraying for low-hanging fruit. That data is a static photograph. It's what was true at 2:35 p.m. on a Tuesday. It's dead the second you save the file. The operator? We build a database, a centralized, versioned data model of the entire attack surface. It is not a text file, it's a living, breathing asset. It's updated automatically every day. It tracks changes. It's a surveillance program, not a port scan.
And this isn't some chaotic free-for-all. It's a pipeline. It's a structured, repeatable process. First, we harden and expand the scope. We find the assets the target didn't tell us about, like that company they acquired last year. Then we do layered DNS enumeration, passive, active, brute force, the whole shebang. Next, we fingerprint every single HTTP service. Not just, oh, it's running Apache, but what's its content security policy? What security headers is it missing? Then we go back in time. We mine internet archives and old source code for forgotten endpoints. After that, we start mapping the humans, the developers, the admins, their vendors. We build a social graph. And only then, when all of that data is in our model, do we run it through our prioritization engine to figure out what to hit first.
And this is how we keep track of the chaos. We're not juggling 1,000 different text files. That's how you miss things. We use a database. Simple, effective. SQLite, DuckDB, whatever floats your boat. Every piece of intelligence gets a home. Every subdomain, every web service, every API endpoint, every leaked secret, hashed of course, every S3 bucket, every developer's GitHub handle. It's all connected,
It's queryable. You can ask it beautiful questions like, show me all staging servers running Node.js, maintained by the mobile team that have exposed a new port in the last 48 hours. Try doing that with grep. This is the power of a structured approach.
All right, let's get into the weeds. The prioritization engine. This is a crucial deep dive because, look, once you do recon properly, you're going to be staring at a mountain of data, tens of thousands of potential targets. You cannot just start poking everything. That's loud, it's stupid, and it's a waste of time. An operator is a surgeon. We need a logical way to score and rank these targets to find the softest, most valuable point of entry. It's time to turn that mountain of data into a goddamn hit list.
Now, this looks complicated, but it's just logic. It's a simplified heuristic, a rule of thumb we use to guide our focus. We weigh different factors. Feature criticality gets the biggest multiplier. Does this thing handle payments? Does it modify user data or permissions? We call that state mutation, and it's a huge red flag. Change velocity is next. Was this feature just shipped last week? We tag it newly shipped because new code is buggy code. Then you have Oz ambiguity. This is a big one. Does this endpoint sit on a tenant boundary? Meaning, does it handle data from multiple customers? That's where you find the really juicy business logic flaws. Then, we add a point for being exposed to the internet, and we subtract points if it's sitting behind a WEF or has other strong defenses. This formula makes the best targets just float to the top.
Let me tell you a quick story. So we're on this engagement, big financial client. We'd mapped everything, subdomains, cloud assets, the works. And it was all locked down tight, hard as a rock. But in our data model, we had their historical ASN records. An ASN, if you don't know, is just a big block of IP addresses a company owns. We saw they had sold off an entire IP block 2 years ago. Just for the hell of it, we decided to scan the whole damn thing. Most of it was garbage, but one single IP lit up on port 443 with a self-signed cert. We hit it, and what do you know? It's a forgotten, pre-acquisition admin portal for some legacy system. No DNS record, not being monitored, no firewall. Default creds still worked. We walked right in and owned their entire back-office infrastructure. That wasn't luck. That was having a complete map.
And this brings us to the elite take. This is what separates us from them. Recon is not a phase. It's not something you do on Monday and then you're done. The biggest mistake people make is running one scan and moving on. For us, Recon is a continuous surveillance program. Your data lake, your intelligence database is automated. It is updating every single day. You should have alerts that fire the second a new subdomain pops up in certificate transparency logs. When their mobile team pushes a new JavaScript bundle to production, you should know about the new API endpoints in it before their own security team does. The goal is to have better situational awareness of their network than they do.
All right, so we've built this incredible map of their external surface. Now it's time to go a layer deeper. Let's talk about APIs. If the network infrastructure is the skeleton, APIs are the central nervous system. It's how modern apps talk, how they think, how data moves, and it's where the most catastrophic, company-ending vulnerabilities live. Why? Because it's where the actual business logic is supposed to be enforced, or, as is often the case, not enforced at all.
Once again, let's contrast the two approaches. The hunter finds an endpoint, like /API v1/users. And what do? They immediately launch FUFF with a generic word list, praying for /API v1/user/admin or /API v1/users.get. It's blind, it's noisy. The operator doesn't fire a single request without a damn good reason. We're decompiling the mobile app. We're parsing the JavaScript bundles. We're carefully reading the error messages. We're building what we call a target native parameter corpus, a custom dictionary of every parameter name their own developers actually use. We're finding the gaps between their public docs and how the API behaves in reality. We form a hypothesis, then we test it. Surgically.
The main goal here, the deliverable that goes right into our database, is what we call the API catalog. It's a living map of every single endpoint we discover, what HTTP method does it accept, what's the auth scheme, a cookie, a JWT, what are all the parameters it takes, and most importantly, what is the state machine? What's the exact sequence of API calls you need to make to add a user, then assign them a role, then give them project access? You see, we're not just finding URLs, we're reverse engineering the soul of the application. The whole purpose of this is to generate testable hypotheses, like I bet if I call the project access endpoint directly and skip the role assignment step, the authorization check will fail open.
And here's the process. It's methodical, not random. First, normalize everything. Clean up the paths, check every HTTP method. You'd be amazed what head and options will tell you.
Second, create a shape fingerprint for each endpoint. Does it require a JWT? Does it expect JSON? Step 3 is where the magic happens. Catalog the discrepancies. The official docs say a field is required, but you send a request without it, and it still works. That's a huge signal. Step 4 is building that target native parameter corpus we talked about. And finally, step 5, you map the crown jewels, the authorization and tenancy boundaries. What does my data stop and your data begin?
Okay, time for another deep dive. Let's talk about one of my personal favorites. It's a high-impact bug class called mass assignment, and we see it most often in patch requests. This little beauty comes from lazy developers who just take a JSON object from the user and map it directly to a database object without filtering what fields are allowed. It's a gift, really, and we're going to show you exactly how to find it.
Here's how you test for this without setting off every alarm on the planet. First, you find a field you're supposed to be able to change, something harmless like nickname. You send a totally valid request, future nickname test. It works. Perfect. Now you take one juicy parameter at a time from that corpus you built, admin, role, account balance, owner ID, and you add it to your request. So now you send future nickname test, admin true. Now you just watch the server's response. If it's a 400 bad request that says unknown field admin, they're doing it right. That's a hard reject. If it just silently ignores your extra field and changes the nickname, that's a silent ignore. Maybe safe, maybe not. But if the response comes back and includes admin true in the JSON body, that's an echo. Or even better, if you just suddenly have admin powers, that's an effect. And you, my friend, just found a critical vulnerability.
Story time. We were hitting this big SaaS platform. The official API documentation for updating a user's profile was boring as hell. It said the endpoint only accepted a single field, description. Useless. But we'd already ripped apart their Android app and were digging through the minified JavaScript. And buried in that ugly mess was a call to the exact same endpoint, but it was building an object with a parameter named entitlements. It was obviously for their own internal admin panel or something. So we fired up Burp, grabbed our low-privilege session token, and sent a patch request with one single line of JSON. Quote, entitlements all, end quote. The server came back with a 200 OK and a new JSON object for our profile that had every single feature flag and permission in the system set to true. One request. Game over. Never, ever trust the documentation.
So here's the elite take, the big picture. Amateurs fuzz inputs. They throw a million XSS payloads at a search box. Operators analyze state. We map the entire application's state machine. We diagram the whole business process. What are the API calls for a new user sign-up, for a password reset, for upgrading a payment plan, for exporting all your data? We look for flaws in that multi-step logic. Can we start the password reset for another user and then inject our own token in step 2? Can we get the upgraded role without actually hitting the payment endpoint? These are the business logic flaws that no automated scanner on Earth can find. This is where the real money is.
Okay, let's move on. We're now entering the modern battlefield. The chaotic, constantly changing, and often terrifyingly vulnerable world of cloud infrastructure and the software supply chain. Forget about finding a bug in a single web app. This is where you find one loose thread that lets you unravel the entire goddamn company. This is how entire organizations get completely owned in one single shot.
And the difference in approach here is it's night and day. The hunter runs a few GitHub dorks looking for AWS_access key ID or scans for public S3 buckets. It's superficial. The operator goes so much deeper. We aren't just looking for one leaked key. We are mapping their entire CI/CD pipeline. Continuous integration, continuous deployment. How does code get from a developer's laptop into production? What build system are they using? Jenkins? GitHub Actions? What open source packages are they pulling in? We're hunting for dependency confusion risks. We're monitoring certificate transparency logs to see every new service they spin up. We are analyzing the factory that builds the car, not just kicking the tires on the final product.
Here's your hit list. These are the surfaces you need to be investigating. Public code repos, obvious goldmine for secrets. Package registries like NPM and PyPy, perfect for dependency confusion attacks. The CI/CD systems themselves are the crown jewels. They hold all the secrets. Storage buckets are just constantly being misconfigured. IAM role definitions tell you who can do what, and they're often way too permissive. Serverless functions and API gateways, often deployed and completely forgotten about. Exposed databases are a straight shot to domain admin. And don't forget the glue. All those third-party SaaS integrations and webhooks. Every single one is a potential door. Now, what's really interesting here is that this shows you don't need some insane $1 million zero-day exploit to own a company's cloud environment. The vast majority of real-world headline-making breaches come from these three simple things. A developer makes an S3 bucket public for 5 minutes and forgets to change it back. An IAM policy is set to allow *** because someone was lazy. A staging database gets spun up for a test and left facing the internet with no password. It's the boring, fundamental stuff that gets people popped, and it's our job to find it before someone else does.
Okay, let's do another deep dive. This one is highly technical and extremely dangerous, so pay attention. We're talking about CI/CD pipelines, specifically a nasty little misconfiguration in GitHub Actions that uses something called the pull_request target trigger. If you find this and exploit it correctly, you get remote code execution inside the target's most trusted environment. You're not on the outside looking in anymore. You are inside the factory.
So here's how it works. Normally, when you make a pull request from your fork of a project, any automated tests run with 0 permissions. It's untrusted code. But some workflows, for convenience, use a different trigger called pull_request_target. This trigger is special. It runs the workflow with the permissions of the base repository, the target's main trusted code. This means it has full access to all the production secrets stored in that repo. The GitHub token, AWS keys, NPM tokens, everything. So, if the workflow script is even slightly careless and, say, checks out and runs code from your malicious pull request, you can write a PR that just prints all of those secrets to the build log. You are tricking their own automation into handing you the keys to the entire kingdom.
Another quick war story. This one's a classic. We're watching a junior developer's public GitHub account. He had forked the main company repo to work on some feature. We're scanning his commit history, and bingo! We find a commit where he accidentally pasted in a production AWS access key. The very next commit message is, oops, remove credentials. He deleted the line of code and pushed it again. He thought he was in the clear. What a dumbass. We just cloned his repo, ran git log-p to view the history with the actual code changes, and there it was, plain as day in red. The key was still active. We had full admin access to their entire AWS org in less than 5 minutes. Remember this, Git never, ever forgets. A deleted commit is never really gone.
And this brings us to the final and most important, elite take. Don't just hunt for secrets. Hunt for the systems that manage and distribute the secrets. Why steal one key when you can compromise the machine that makes all the keys? A compromised CI/CD pipeline is the absolute holy grail. It is infinitely more valuable than a single leaked API key. A key can be found and revoked in minutes, but if you own the pipeline, you have persistent, trusted access. You can inject a backdoor into any build. You can deploy malicious code directly to their production environment whenever you want. Owning the factory is always better than stealing one car.
So let's start to wrap this first session up. We have covered a hell of a lot of ground. We've talked about the operator mindset, we've gone deep on foundational recon, API deconstruction, and the modern cloud and supply chain battlefield. We've given you the blueprint for building a total intelligence picture. The key, the thread through all of this, is that mental shift from finding one-off bugs to planning and executing a coordinated campaign. Now, let's talk about what comes next.
All right, let's nail down the key takeaways. 1. Think in graphs, not lists. Understand the connections between assets. 2. Your data model, your database is your primary weapon. Treat it as such. Keep it clean, keep it updated. 3. Be a surgeon, not a demolition crew. Test with precision and a hypothesis. 4. Hunt for flaws in their business logic, not just dumb input bugs. That's where the real impact is. 5. Automate your recon. Monitor for change. You need to be the first to know when something new appears. And finally, 6. The goal is always a complete, total intelligence picture of your target's world.
So when is recon over? When are you ready to actually start breaking things? Here's our exit criteria. You are ready when your prioritization engine has spit out a hit list of at least 10 high-intent targets. I'm talking about API endpoints that you've tagged state mutation or tenant boundary, the juicy stuff. You should have a backlog of solid, data-driven hypotheses that will keep you busy testing for days, not minutes. You don't make a move until you have a plan, a backup plan, and a backup plan for the backup plan.
So we're going to leave you with this final thought. After applying everything we've talked about today, you've done the work, you have a complete map of the entire kingdom. You know its supply lines, its defenses, and you have the credentials for the gatekeepers. You own the building. So the question is, what's your first move? That's what we'll get into next time. We'll see you then.